Dengan kondisi ini, saatnya kita kerja dari rumah, belajar dari rumah, ibadah di rumah.
It's been a year in pandemic situation. Many activities have to be postponed or cancelled due to strict health protocol and social restriction. This causes human mobility to decline, especially in Indonesia. The increased mobility of people in the past year as a result of the work from home on post-pandemic COVID-19 turned out to be stressful for some people. There are many causes of stress arising from the pandemic and activity work from home. Although the condition of the house is less comfortable for the occupants. Comfort in an aspect. This is very much considered by humans. Talking about the comfort aspect of home when working from home. The use of the Internet of Things based on smart home can be used to support the comfort aspect for residents of the house for a long time. The application of basic Internet of Things in smart home very likely to be implemented to provide certain comfort including aspects of thermal or lighting. The Internet of Things architecture of smart home system base is designed to function to support the comfort aspect needed by occupants of the house. The comfort parameters used are in the form of thermal comfort and lighting aspect of the room, which are often used by residents. The IoT concept is applied to a smart home system using a client-server-based microcontroller. Server device that function as a data collector for thermal and light intensity in the room. The hash data obtained for test to sensor input are issued by smart home logic, which has been designed to be sent to the client device via one-way communication to the MAC address of the client device. The client device is a microcontroller integrated with an light dimmer sensor and an infrared transmitter sensor as the output of the desired smart home system.
Components used in building a smart home system is the main components in the form of two pieces ESP8266 as a server-client communication program by Arduino IDE. BH1750 sensor to measure in the light intensity. The HT11 sensor to measure thermal values indoors. An AC light dimmer module to control the intensity of room lights with pulse width modulation. An infrared transmitter module to control the room air conditioner. And two pieces AC to DC adapters as power supply to the microcontroller and the AC light dimmer module. This device works automatically when supplied with power. The command begins by checking the availability of sensors connected to the server device. This sensor measures the value of thermal and light intensity which is located at the farthest location from the light source, and is not the direction of the air exhaust ventilation from the air conditioner in the same room. The input value from the sensor is then processed with the designed smart home logic. This logic contains a method of determining the next command, that when the sensor value is less than the set point, the server device will send commands to the client device to increase the light intensity of the lamp, and send command codes to turn on and increase the temperature through the air conditioner. Meanwhile, when one or both of the parameter value of the sensor exceed, it will instruct the client device to turn on the air conditioner or reduce the intensity of the light. Meanwhile, the client device is placed in front of the air conditioner parallel to the infrared receiver sensor of the air conditioner. For market opportunity, the design of the smart home is devoted to meeting the aspects of the thermal and lighting comfort. The main focus is to make the occupants of the house comfortable with the integration of the smart home system, and it can reduce the stress level of the occupants due activities work from home long term.